Hi, my name is Chris and I'm from the group IO2, and in this video I'll be showing you our group project for computer vision, the filter gallery. I'm paired with 3 other people, Araporn, Pakanan, and Komsanti. Let's start with an overview of the concepts behind our process. Our image processing software is built around 6 key techniques: feature extraction, image downsampling, image transformation, image reconstruction, edge detection, and image segmentation. Feature extraction allows us to adjust the mood and tone of an image by modifying its key characteristics. This can be useful for tasks like enhancing contrast, applying filters, or detecting specific objects with an image. Image downsampling and color quantization simplify an image by reducing the number of colors and details, creating a pixelated image similar to old-school video game graphics. Image transformation allows us to modify an image's position and shape through translation, rotation, and shearing. This is essential for realigning and distorting image while maintaining its structure. Image reconstruction focuses on cartoonization, which applies artistic effects to make an image look like hand-drawn illustrations. This technique can be used for stylized filters or even AI-generated artwork. Edge detection converts an image into a sketch-like representation by identifying the most prominent outlines. This is useful for applications like handwriting recognition or object detection. And finally, image segmentation, which removes the background, isolating the subject of an image, and this is commonly used in photo editing, green screen effects, and even computer vision applications. Now, before diving into the specifics of the features, let's talk about why we chose this process in the first place. There are 4 main reasons: knowledge, business opportunity, and creativity. First, this project directly connects to what we've been learning in this course. It applies image processing techniques like feature extraction, edge detection, and image transformation, making it a great way to reinforce those concepts. From a business perspective, this could be a starting point for developing image editing software or filters that could be useful for platforms like Instagram and Snapchat. These companies rely on image processing, so the project could help us understand how familiar technologies work. It also gives us an opportunity to expand on what we've learned. By building this project, we can explore more advanced techniques like cartoonization and pixelation, which allows us to go beyond the basics taught in class. Finally, there's creativity. Since we're using various image processing methods, there's no limit to the kinds of edits that we can make. The output can be highly customizable, opening up possibilities for new filters, artistic effects, or even AI-powered enhancements. Most importantly, this project is manageable within our 1-month time frame, making it a realistic, effective choice. It also solves our need to edit and adjust photos as we please, making it a useful and practical application of what we've learned. Now, to image properties. When you select an image and click on the Image Properties button, our program retrieves various details of the image, including its dimensions, bit depth, file size, and format. First, our program loads the image using OpenCV. If the image cannot be loaded, an error message is displayed. Then we use the Python imaging library to extract metadata such as DPI, which defaults to 96 if it's not available. Next, we retrieve the image's width and height in pixels. This information is stored in a list and will be displayed by the user. To determine the image's bit depth, we check whether the image is grayscaled or colored. If it's grayscaled, the bit depth is based on the data type of its size. If it's an RGB or RGBA image, we multiply it by the number of color channels. We also calculate the file size by converting it from bytes to kilobytes or megabytes for better readability. Finally, we extract the image format for its file extension. Now let's talk about the gray feature in our software. This function converts a colored image into grayscale using luminosity, which helps maintain brightness as perceived by the human eye. When you click the gray button, the program processes the image by first checking its data type. If it's not already in an 8-bit format, we clip the pixel values to stay within the valid range of 0 to 255. Then we split the image into 3 channels, red, green, and blue, using OpenCV. To create the grayscale image, we use a weighted formula with 0.299 on red, 0.587 on green, and 0.114 on blue. These values ensure that the green channel has the most influence, since human vision is most sensitive to green light. After that, we convert the computed grayscale values to an 8-bit format to properly display. Finally, we stack the grayscale image into 3 identical channels so that it remains compatible with other image processing functions. On the screen, you can see the original colored image on the left and the grayscale output on the right. The grayscale version removes all color while keeping the brightness level as close to reality as possible. This feature is useful for image pre-processing, edge detection, and various other applications where color is necessary. That's all for grayscale. Next, we'll be moving on to black and white function, which takes grayscale conversion a step further.
Now I will discuss about black and white feature. Here is the flowchart of black and white feature. You can see the function where each method in this line. And here is the difference between lowest box size and highest box size. This is an adjust photo feature user interface. You can adjust brightness, contrast, highlight, shadow, saturation, vibrance, temperature, and also adjust the color channel, blue, red, and green. For the brightness adjustment, the image is converted to HSV, hue, saturation, value, color space. We adjust the V value channel to make the image more brighter or darker. Example shown here. If an image is too dark like this, you can increasing the brightness, make more detail clearer. And if an image is too bright like this, you can decreasing the brightness to prevent the overexposure. For the contrast adjustment, we use the formula alpha equal to 1 plus value divided by 300 to increase or decrease contrast. If alpha greater than 1, the contrast is higher, making dark area is darker and bright area brighter. And if alpha lower than 1, the contrast is lower, making the image softer. In this value 300, if we change 300 to 100, the effect of contrast adjustment becomes stronger, meaning small change in value will create a bigger difference in contrast. You can see the result of increasing contrast and decreasing contrast here. Now the highlight adjustment. The system detects pixels with V-value greater than 127 and adjusts their brightness accordingly. This prevents overexposure while maintaining image details. And you can see the result of increasing highlight and decreasing highlight here. Increasing highlight will make bright area even brighter, which can add a glowing effect. So for the decreasing highlight, this can recover detail from overexposure area. Now for the shadow adjustment. Shadow controls the darkness of the darkest area in image. The system detects and adjusts the shadow, brightening dark area without affecting bisection. And here is the result of increasing and decreasing. For saturation, this controls the intensity of color in an image. Higher saturation makes color more vibrant, and lower saturation makes color more dull. And at the lowest setting, the image becomes a grayscale. Increasing saturation too much can make a color look unnatural, and also reducing saturation slightly can create a soft and professional tone. Now is the vibrant feature. This feature is calculate the mean saturation level and adjust less saturation area more than high saturated ones. Vibrant is useful for making portrait look natural without oversaturating skin tones. It keeps extreme color from becoming too strong. Here is the result of adjusting vibrant, and you can see the function here. In 200 value here, if you change to another value like 100 or 300, it's also affect like the contrast function that I explained before. We can change this value. Now let's go to the temperature. If we increasing the value and add more light, it's creating a warmer look, and if we decreasing the value and add more blue, it's creating a cooler look. You can see this one, this one. This is more blue and this is more red. We can use this function to making a winter photo look colder by increasing blue tone, or making a sunset photo more warmer by increasing a red tone. For the adjust photo feature color channel, this feature allows independent control over the red, green, and blue channel in the image. You can see the color separate in blue part, green part, and red part. If we increasing red, this can make a skin tone look warmer and more vibrant. And if we adjusting again, this can help the color imbalance in nature photography. Also, you can change the value, this one 300, 500. If we change 300 to 500, it also work like a contrast function.
So now we're going to talk about image transformation. So of course, like any other process that we've done so far, we need to have a parameter to be adjustable by the user. So we decided to add some GUI elements from Tkinter, which is the scroll bar, just so that the parameter adjustment process is a bit more interactive. And we cannot forget to use dynamic variable from Tkinter, just so that everything is in real time and we don't have to click update all the time. But still, we still need to have apply and reset, just so that the user can adjust everything and then click apply everything at the same time, since that's more intuitive. Now, the first process of this one is translate. Nothing much here. We have a 2x3 matrix with two variables inside, which is tx and ty. So tx will cause the image to rotate in x or horizontal direction, and for y it will be in vertical direction. So for this one, we create a matrix and then we put in a function called warp affine, which basically takes the matrix and then apply it to the image. We also have border value just for changing the color every time the image shifts out and we want to change the color of the background. Shear. So for shear, it basically is pushing the image in certain direction to cause it to deform. So we have two variables, SHX and SHY, which receive from the scroll bar as well. And this is the matrix. As you can see, they look kind of similar like the one we use for translation, but this time our parameter is in like this fashion. We also use warp affine, just like translation, but the parameter is a bit different here. Okay, so we have new width and new height. This basically change the dimension after the shear. So yeah, this is shear. As you can see, this is the result. We have horizontal shear, which deform the image in horizontal direction. We also have vertical shear, which vice versa deform the image in y direction. Now we have scale. Scale is one of the most intuitive ones, but there are some special details. Of course, we have parameter. This is misspelled. It's supposed to be something else, not SHX and SHY, but that's okay. So the code here, basically we have two methods. For cv2.interior, basically it's for shrinking because it preserves detail a bit better. We also have cv2.interlinear, which is very good for enlarging because it's faster and smoother. And this is the result. Okay. Now we have image transformation, rotate. Okay. For rotate is quite simple. We have parameter angle, and then we put it inside a matrix. But this time we are not creating the matrix from scratch. We use a method, a function from CV2 called getRotationMatrix, and then put our angle in here. And then the image will rotate just like the angle we put in.
Now let's move on to our next feature. As you can see from the flowchart, the first step is that we resize the image down by dividing the width and height by the pixel size input. This makes the image smaller, so it contains fewer pixels. With fewer pixels, each pixel now represents the average color of the group of pixels from the original image. This gives the image a blocky look, similar to classic pixel art. Next, we reduce the number of colors in the image. the color levels input control how many different colors the image will have. A lower value means fewer colors, which make the image look more retro. The fewer colors we use, the more old school or pixelated the image will appear. Finally, we resize the image back again to its original size. When we scale the image back up, we use nearest neighbor interpolation. This means that the pixels stay rocky and don't get smoothed out, maintaining the pixel art style. So here is our example to compare with the different size of the size and color level values. So as you can see, if the size of pixel get larger, it will be more larger of pixel. And if the color level is larger, it will show more variety of the colors. Now let's move to next feature, sketch feature. The process started by converting the image to grayscale. After that, we will apply blur effect to soften the image, making the details less sharp. Then we invert the image so that the light areas become the dark and the dark areas become light. Next, we apply Gaussian blur to the inverted image, which smooth out the transition between light and dark areas. Finally, we combine the original grayscale image with the blurred and inverted image to create a pencil sketch effect. Optionally, you can invert the result again to get a white sketch on a dark background, depending on your preference. The result is an image that looks it has been drawn with a pencil with a clear edge and soft shading. So as you can see, we input a blur size and intensity here, and you can tick for invert effect if you prefer. So is it our example, the cat over here. So the step to be easy to understand is that first step it will convert it to grayscale and then inverted grayscale, then use the Gaussian blur and inverted blur image, and then dimension result to get this picture. And if you want to invert it for your preference, you can just like this.
Okay, so now I'm gonna talk about document scanner. So let's say we have an image which is just a normal looking image of your document, but this is quite hard to read, and sometimes we want to stretch it so that it's like a scanner printer, okay, but we only have this image, so we need to process it somehow to get into perfectly 2D, and then we process it to make it a bit more readable. So as you can see, we have this process here. We start from resizing the image, turn it to grayscale, and then we blur it. Then we use edge detection canny. Okay, we're gonna get out the edge. After that, we're gonna perform something called contour detection, which will detect the sharp corner like this. After that, we should be able to get the 4 corner of the document, or sometimes we use 3 as well. And then we perform something called perspective transformation, which we will get a perfectly 2D image of our document. But this may not be enough, so instead we apply grayscale and then we apply trash binary to make everything a bit more clear, make the text a bit more stand out. This is the code, just like the process I've shown so far. So we have gray, we have Gaussian blur, and then we use canny to get the edge. Then we use this thing called fine contour, which is basically what we did with the process image to get the corners, the sharp corners. Okay, and then we have contour to rect, which will turn everything, the point that we found into 4 corners. And then we perform warp perspective, which will allow us to get the 2D image. And after that, it's all about detailing. We just change everything to grayscale and then we use trash binary to make it more readable.
Now let's move to the next feature for the remove background. First, we make a copy of the image and create a mask to separate the foreground from the background. Then we initialize the gap cut algorithm, which helps to segment the image. This algorithm uses select control to define the area of interest and run a few iterations to refine the mask. So as you can see from the gap cut here, it will return 0 for the exact background, and 1 for the exact object, and 2 for the possible background, and 3 for the possible object. So after that, they will create a new mask where all the background area are set to 0 and foreground area are set to 1. So the part that I mentioned it will goes to here np.where. It will change the 0 or 2 which represent as a background to be a background. So basically just change the gap cut return to be the 0 or 1, that's all. Then it will multiply the original image by this mask and keeping only the foreground. The result is an image with the background removed, leaving just the subject of the photo. So to be more simplified is that the gap part is turn out this value, right? And then it's changed to the 0 or 1. So imagine if you put the 1 and 3 over here, it will be remove the object instead of the background. So basically the main feature is goes to the gap cut feature, gap cut function. Now, here are some examples of our remove background feature. As you can see, the iteration and the max iteration. For the minimal iteration, they will not remove all of the background, but if the iteration is high, it will clearly remove all of the background almost. And for the maybe just for the simple feature like this butterfly, yeah, it can clearly show that it start remove the background. And as a Mario over here. Now for the cartoonize features, the first step is convert the image to grayscale so that we can focus on the shape and texture rather than the colors. We can apply median blur to smooth out the grayscale image. After that, we use adaptive thresholding to create edge in the image. This edge will help to define the cartoon effect. The next step is to apply bilateral filter to original image to smooth the colors while keeping the edge sharp. Finally, we combine the filterless color image with the edge, creating a cartoonized effect. The final result is an image with the bold and dark outline and smooth colored regions, resembling as a cartoon drawing. So as you can see, the function is just paste the cartoon effects. So this step for easy to understand is that the first, as I said, it will convert to grayscale and then blur it with the median blur, and then it will detect the edge, and then smoothing, and then they will combine the edge and smoothing together. As you can see, just like overlap here, and it will be result as a cartoonized image.
Now let's talk about the ideas for improvement. While our project is functional, there are still some limitations we've encountered. One issue is with the remove background feature. In some cases, the program doesn't fully remove the background or leaves behind unwanted artifacts. This means that certain images don't process correctly, especially if the background is too complex. Another limitation is that in the scan document feature, for the function to work properly, the input image must clearly show all 4 corners of the document, and the background needs to be a different color from the actual document itself. If these conditions aren't met, the feature struggles to detect and process the document correctly. To address these issues, we need to explore alternative techniques that are more adaptable and precise, finding more advanced algorithms that could help make the background removal and document scanning features more reliable across the different types of images. Aside from improvements, we also have some additions that we'd like to implement in the future as well. First, we want to expand the software's compatibility to support more file formats like MP4 so it can handle video processing as well. Another useful feature would be adding support for 3D printing and CNC-compatible file formats like SVG and G-code, making the tool more versatile for different industries. To improve efficiency, we plan on implementing asynchronous processing, allowing the software to handle tasks faster by running multiple operations simultaneously. We also see a lot of potential in integrating generative AI, which could open up new possibilities for image editing, such as face detection and beautification filters that apply AI-driven enhancements. These improvements and additions will make our software even more powerful and adaptable, allowing it to be used in a wider range of applications. This wraps up our project explanation. Thank you very much for watching.